Alright, so today we're going to be talking about energy and the various forms of it. We're also going to talk about how transformations occur, how they change from one form to the next. So we're going to start with just a quick review of what energy is. So energy is the stuff that makes stuff do stuff. So it's our ability to do work. Previously, we were talking about what work is, and we said that its equation is force times distance. So we have to be able to move that object a certain amount of distance in order for it to actually be considered work. We measure work in joules, which is actually the same thing we are going to be measuring energy in. So these are very closely tied together. Energy is the reason we're able to be here today. It's extremely important that you understand the different forms. So the two main types of energy are kinetic energy and potential energy. First, we'll talk about kinetic. So that's the energy of motion. Anything that is moving has kinetic energy. We have an equation so we can figure out how much kinetic energy an object has. So that equation is 1/2 of the mass, which is measured in kilograms, times speed squared. And we measure that speed in meters per second. Okay, so we can simplify that by saying kinetic energy equals 1/2 mv squared. V stands for velocity, which is speed. Okay, so we'll be using that equation more in class. Just have it written down for now. Potential energy is stored energy. So it's the amount of energy something has stored up so it has the potential to do something. So it's not doing something yet, but it has that potential to because it has energy stored. We're going to talk about the main types of potential. There are two different types we'll talk about. The two types are gravitational potential energy and elastic potential energy. Gravitational depends on the height of an object. So how high something is above the ground so that gravity pulls it back down. That would be gravitational potential. The equation for that is mass, which is measured in kilograms again, times gravity. And gravity always equals 9.8 newtons per kilogram here on Earth. Okay, so that will be the number you use in this equation. And then you multiply all of that by the height that object is at in meters. So gravitational energy, a lot of it depends on the height. So this little monster right here, let's say I hold him up higher. Okay, so he has more gravitational potential energy right now than if I were to hold him down here, down lower. So based on the height, tells us how much potential energy he has, basically to fall down to the ground. The other type of potential energy we have is elastic. Elastic potential energy is occurs when something is stretched or compressed. The best way to remember that is to think of a rubber band or an elastic. So if you stretch that out, it has more potential energy than if you leave it just relaxed. Okay? We all know you can stretch it more and make it fly. Okay, so that would be an example of elastic potential energy. The opposite would be if we compress something. We squish it in like a spring. That spring, you squish it, and then release it and it will spring back up. So that is elastic potential energy. Now we have 6 forms that energy can take, and we classify those different forms as either kinetic or potential, or sometimes both. So we're going to go through each of those 6 forms, but they are mechanical, heat or thermal energy, chemical, electrical, electromagnetic, and nuclear. So you will be filling in that chart on the bottom of your page, and it flips over and continues on the back. So the first one we're talking about is mechanical energy. So this is energy of motion or position. So because it's of motion, that would mean kinetic, or position, which also means potential. So based on where that object is, like my little monster, being up higher, that gives him mechanical energy to fall, and that's motion. So that's kinetic and potential. Okay, so some examples we have of mechanical energy are sound, wind, a waterfall because it falls from a higher place to a lower place, or a compressed spring, like I was talking about before with elastic potential. The only thing to remember with mechanical energy is it's not 100% efficient. So a lot of it is lost, okay? So when it changes from one form to another, we're going to lose a lot of that energy as heat. Speaking of heat, that's the next one we're going to talk about. So our next form of energy is heat or thermal energy. This one is the measurement of the internal motion of an object's atoms and molecules. So when we're talking about the states of matter and phase change, we talked about kinetic theory and how those particles are constantly moving. They're never stopped. Due to that, everything has thermal energy. So to measure that thermal energy, we use temperature. So temperature actually is measuring how much those particles are moving around. The faster those particles are moving, the more thermal energy they have. Okay? Another thing to keep in mind is because they are moving, that's kinetic energy. So kinetic energy, just to remind you, is energy due to movement. So these particles are moving, they have kinetic energy. Our next form of energy is chemical energy. This one is energy that is stored by chemical bonds in an object. So all objects are made up of chemicals. Those chemicals have somehow bonded together to hold them in. When those bonds are broken, they release an energy. Now we're talking about stored energy. Again, stored energy is potential energy. So that's why chemical energy is potential. Some examples of chemical energy we have are gasoline, food, coal, wood. These are all things that we burn or use to get the energy that's stored inside them. So coal and wood, a lot of times we will use that to keep us warm. So you burn your wood in your fire, it releases that energy in the form of heat and it keeps you warm. Another thing is food. We eat food so that we have the energy to go out, run that mile that you guys have been all tested on. We also eat food so that we can have the energy to get to class on time. Okay, so food we know is very important for us. It gives us that chemical energy that we need to then convert and use. Next type of energy is electrical energy. This one I know you guys are all thankful for your cell phones and your laptops and whatever else. It's the reason that I'm able to give you this video. Without electrical energy, we wouldn't be able to be sitting here right now. So electrical energy is the moving electrical charges. Now moving, that gives us a big hint at what type of energy this is. So this movement tells us kinetic. So this is a form of kinetic energy. So we use electrical energy to get our electricity. We get this from batteries, the batteries in your remote, the batteries in your cell phone, batteries in my laptop I'm recording this on. We also get it from our power lines so we can turn on our lights at our house, and lightning. So that is where we first started studying electricity from. Next type of energy we have is electromagnetic energy. This one is extremely important to us. As an example of it is light. We need light. Okay? Otherwise we would not exist and our plants would not be able to go through photosynthesis to make the food they need, to give us our oxygen, all of that. So this is the type of energy that travels in waves. It has electrical and magnetic properties. So that's why we call it electromagnetic. The examples, like I said, are light. We also have magnetism, X-rays, so you can check to see if you broke your arm or your leg or anything else. We also have radio waves, so you can hear the latest songs on the radio, microwaves heat up your food, ultraviolet and infrared radiation. Those are all forms of electromagnetic energy. Because that energy is traveling, it's traveling in waves, right? So those waves are still movement, so it still means it's a form of kinetic energy. So electromagnetic is kinetic. The last type of energy that we have is nuclear energy. So this is energy that's stored in the center of an atom. The center of an atom is called a nucleus. So in that nucleus, we have a lot of energy stored. Since we're on that topic, stored energy is called, again, potential. So nuclear energy is a form of potential energy. Now there's two types of nuclear energy. We have fission, where it breaks that nucleus apart, or we have fusion, where we take two different nuclei and they fuse together to form a new atom. Alright, so fusion is used in our sun. Our sun takes two hydrogen atoms, fuses those nuclei together to form a helium atom. That releases a lot of energy. This is the most powerful form of energy. Our power plants, when we talk about nuclear power plants, which we have a few of here in Connecticut, it uses nuclear fission. Fission is when we break those two apart. So we start with one, break it apart, it releases a lot of heat, and then we change that into electricity for our homes. So energy is extremely important. We change it from one form to another. Now you know the 6 basic forms. We'll be able to classify what we're starting with, what we're ending with when we continue with energy transformations. So now that's the end of our show. Just take a minute to write down a couple questions you want to ask me tomorrow in class. And if you need to, go back through this slideshow, pause, rewind the video as many times as you need so you can be prepared for the rest of our unit. See you tomorrow.